Welcome to Xamarin University. This session is XTC102, Working with Xamarin.UITest. Please be sure to download the class materials from the Xamarin University website. Today, we're going to introduce you to the foundations of creating acceptance tests for your mobile applications using C# and the Xamarin.UITest framework. We'll look at the basics of UITest and getting the project structure and your environment properly configured. Then, we'll dive into creating acceptance tests and the API that you'll use to drive your application and writing the logic to test it. For this class, we'll be focusing on local tests with the simulator. But eventually, you will want to run your tests on real devices locally and then broaden your testing with different operating system versions and form factors, which is where the Xamarin Test Cloud product can help. We cover all of those details in a follow-up class, XTC103, where we will take these UI tests and then set them up to run on Test Cloud and local devices. So let's start by looking at how to create a UI test with Xamarin Studio and Visual Studio. We've got several things that we want to look at here. We'll start by defining what UI test actually is and how to create a UI test project. Then we'll look at one of the great interactive features of UI test, which is the REPL window. We'll use this to execute some basic queries and then put it all together to see how to create acceptance tests. So what is Xamarin.UITest? Well, Xamarin.UITest is an automated testing library that allows you to directly interact with the user interface for both iOS and Android applications. You can query the UI and find out information about the controls on the screen and use that information in your tests. You can even drive functionality on the screen by entering text and clicking buttons. It lets you harness the power of the C# language to create readable, first-class acceptance test code right in Visual Studio or Xamarin Studio. You can then take those tests and run them locally in your simulator or on your physical devices and get the results in the same testing UI that you use for unit tests. Xamarin.UITest is based on Calabash, one of the world's most popular automated testing frameworks for mobile apps. This framework presents a uniform interface to cross-platform testing for any iOS or Android app, including non-Xamarin applications, and even hybrid apps that leverage HTML and CSS in web views. To give you an idea of what you can do with UITest, let's look at the code on the slide. Here we have several commands and code that are being executed against a user interface. We're tapping a button, we are entering some text into a control, and then tapping the Save button. This code is automating the UI so that we don't have to manually perform these steps. Now, if you're starting a brand new mobile application, then it's possible that the templates we'll create that app will already include a UITest project. This is currently in Xamarin Studio and will be in Visual Studio as well. If you already have an application and want to add UITest to it, then the easiest way to get started is to use the UITest project templates in Xamarin Studio or Visual Studio. And there are 3 of them. Each are located in a specific category. The cross-platform category creates a UITest, which can be shared between different mobile projects. It separates out the initializer logic into a shared piece of code for iOS and Android, and then executes the UITest for both those platforms using 2 test fixture attributes, one for each platform. And this approach is great if the UI between your platforms is fairly consistent, and so we can share the tests that will drive the UI. For example, most Xamarin.Forms applications will fall into that category. If that's not the case, or you're only wanting to test a specific platform, you can create a platform-specific UITest project, and you'll find a UITest template in both the iOS and Android sections. The created projects will have all the proper references and some sample initialization code set up for you to fill in. You can create a Xamarin.UITest project in Visual Studio as well. It's just called UITest here, and it's located in the Visual C# category under the Mobile Apps section. It will create the same cross-platform project, which can support either Android or iOS or both. Since there are a lot of templates in Visual Studio, the easiest way to find it is to use the search bar at the top right and search for UITest. Now, we're almost ready to start writing some UI tests. However, there is a little more setup that we have to do. The UI tests you write are contained in a class library which is run through NUnit. To drive the application through the tests, Xamarin.UITest relies on an automation library called the Xamarin Test Cloud Agent. This automation library is what lets your acceptance tests drive the application. It's important to recognize that you can only interact with your specific app, not with the phone system in general. So, for example, you can't hit the home button and activate a different app, or go into system settings and set some value there. The tests only interact with the application they are testing. Now, as I mentioned earlier, UITest sits on top of an open source project named Calabash, which is an acceptance test library built around behavior-driven development. UITest provides a higher level C# abstraction, which is a bit easier to work with if you haven't done much with acceptance testing before. But if you'd like a deeper look at Calabash and what it can do, check out our XTC102 class focusing on Calabash. This automation library has two parts to it: a client, which is utilized by UITest itself and is part of your test class library, and a server, which is actually run on the device or simulator and performs the automation activities using the platform automation APIs. These two sides communicate through a network connection established between the client and the server components. On Android, which you can see on this slide, the automation server is installed onto the device or emulator along with your application, and it runs as a separate process. To bypass the normal sandbox conditions, the server component is signed with the same key as the application, so it looks like it's part of the same app. The deployment step takes care of all of this for you. On iOS, the architecture is a bit different. The server is actually bundled into your application that's being tested using either a NuGet package or a native component, which we'll see in a moment. Since it's integrated into the application bundle, it can drive and control the application, as directed by the client-side agent and your UI tests. To embed the server component into an Xamarin iOS or Xamarin.Forms application, you can simply add the Xamarin Test Cloud Agent component to the Xamarin iOS application. You can get this component from either NuGet, which is the preferred location, or from the Xamarin Component Store. Again, to be clear, you'll be adding this into your actual application, not to the testing project. In a Xamarin.Forms application, you would want to add this to the native Xamarin iOS project, not into your shared code project. And one of the great things about Xamarin.UITest and Test Cloud is that it can test any iOS or Android application. The test will still be written in C#, but it's just driving the application through the same screens and steps that you would use if you were testing it manually. And that means it can test applications built in other languages, like Swift or Java, or even a vendor's cross-platform tools like Cordova. For Xcode-based apps, we'll still need to embed the automation server in the app. However, we can't include a NuGet package since that's a .NET thing. So we have to embed Calabash using an Objective-C library that you can grab from GitHub. And this same library can be added to a Swift application to allow it to be automated with UITest. For more information on this, go to the link you see here on the slide for the GitHub repository. Now, once the server is included in your iOS application, you'll need to start it as part of your application's initialization. And the best place to do this is in the finished launching override. You start it through a call to the calabash.start, and it's exposing a bit of the underlying plumbing by its name. Make sure to use conditional compilation to perform this step. You don't need or want the automation server in your final released application. The templates that you will use, they use the symbol enable test cloud, but you can pick any symbol you like as long as it's defined as part of the build you create for testing. For example, people will often use the debug symbol. The point is that we want to make sure that no code is referenced in the release builds so that the entire component is thrown out by the linker. The latest iOS application templates will include all this code for you, but if you're adding support to an existing iOS application, then you need to add this single line of code to start the server. There are also some steps to initialize the UITest framework itself. We need to define what application we want to test, how to locate it, and then ask UITest to start the app. All of this is done in the template projects through an NUnit setup method, which is executed prior to each test method. This initialization is platform specific, and in the cross-platform UITest project, the initialization is actually separated out into an app initializer class, which contains a start app method, that is passed the specific platform to initialize. You can see the basics of this method in the code on the slide. The static method is called from the setup method in the test fixture. In the iOS and Android specific styles, the initialization code is placed directly into that setup method. Now let's begin with our first group exercise. Together, we're going to explore creating a new UI test project. I'll be using Xamarin Studio, but you can open whichever IDE you prefer and follow along with me. We'll begin in our IDE. So first, let's start by creating a new solution. And we'll take a look at the different templates we have for us. If you're in Visual Studio, you'll only have one UI test project template. You can search for that. Just search for the string UI test. Here in Xamarin Studio, under the cross-platform test category, we have a UI test project template. Under the iOS test category, we have another UI test project template. And under Android test category, we have a third UI test project template. For this demo, we're going to focus on the cross-platform test project template. So go ahead and select that one. Click Next. We'll give our project a name. I'll just call this Test Demo. And we'll click Create. So we've now created our solution here with a single project. The first thing to notice is that the UI test framework is delivered as a NuGet package, and it's most likely out of date. So we can update the NuGet packages for the project to ensure that we're starting with the latest stable version. And now that those packages are updated, let's take a look at our project that got created. Notice that two files have been created for us here, the appinitializer.cs and tests.cs. The test.cs file contains the scaffolding for our NUnit tests. You can see here that we have the test fixture attribute defined. In fact, it's defined twice, once for each platform that we're testing. The test class itself is receiving the platform parameter in its constructor. Then before each test is run, we'll use the setup attribute, and we then call the appinitializer.startApp method, and we pass the platform in. In the startApp method, we need to configure our app depending on the platform. Let's talk more about that configuration now. In order to start automating our tests and automating the application, we'll use the iApp interface in the UI test framework. This is an abstraction that provides all the testing APIs that we'll use to drive either an Android or an iOS application. UITest currently provides two concrete implementations of the interface, one for iOS and one for Android. However, you do not instantiate these directly. Instead, we'll use a static class named ConfigureApp to build, configure, and ultimately create the iApp we'll use for testing. Our tests should be independent and not rely on any state set or created by a prior test. And because of that, we recommend that you build the iApp interface prior to each test being executed. This will prevent state from one test spilling over into another, affecting the results and the reliability of the tests. Since we're using NUnit as our test runner, you'll generally initialize the iApp interface in a setup method of a test fixture. This is the default, and it's what the project template will create. This method will run prior to each defined test in the fixture. If there's just one test in the test fixture, you could also use a test fixture setup attribute and method to create your iApp. And then to get the iApp interface, we'll use the ConfigureApp static method, which uses a fluent syntax to perform all the initialization and setup tasks. It starts with identifying the platform. There's two properties on it today, iOS and Android, which will obtain the concrete implementations. You will then typically cache off the result in a field of the test fixture for each of your tests to use. But identifying the platform isn't the only piece of required information. We also need to identify the app that we want to test. There are three ways we can identify the application we want to work with. First, you can specify an iOS app bundle or an Android APK. You must specify the full path although a relative path is fine if the application is always in a location off the UITest project itself. And this is useful if you have a dedicated QA team, which can take the delivered binary from the development team and run tests on it. And with this approach, you're specifying the binary, not the source code. So again, this binary can be produced through any app development mechanism. It doesn't have to be a Xamarin-based application. UITest doesn't care what technology you use to build the app. It just installs the binary and interacts with its native UI. So here's an example of configuring UITest to launch a specific binary in iOS and Android. On iOS, we use the app bundle method. This takes the path to an app bundle. On Android, we use the APK file method, which takes the path to the built APK file. One thing to be aware of when you use this approach, on Android, you must launch the emulator before you run the tests. On iOS, there's a different issue. It will launch the simulator for you, but it won't install the app bundle if there are spaces in the path. So be aware of those restrictions. And then finally, you must supply the full path of both of these APIs. It can be a fully qualified path and file name, or you could use a relative path based off the UITest project folder. And that can be useful if the app that you want to test is in the same solution or is checked out from your source control system with the tests. The second mechanism you can use is to identify an already installed application by the package or the bundle identifier name. This allows you to test apps that were installed through some other mechanism. For Android, this means you can test pretty much any app on the device. For iOS, recall that we need the Xamarin Test Cloud Agent server component, so you can really only test apps that you can build from source. To identify an app on the simulator or the device, we use the installed app method. This same method is used on both iOS and Android. On iOS, you need to specify the bundle identifier, and on Android, you use the package ID. When the tests are executed, the system will launch the app on the device and begin running the tests. The final mechanism that you can use is to point your test project at another project in the same solution. This feature is currently only supported in Xamarin Studio, and it requires that the UITest project is located in the same folder as the application. In other words, they must share the same common parent folder. You can't identify an app located in a completely different folder. This project structure is the default when you're creating a new solution, and it's easily adjustable, so if you want to use this approach, it's not hard to set up your solution structure to match this requirement. And this is by far the easiest way to set up the tests, but again, it requires Xamarin Studio at this time. This is actually done for you automatically if the UITest project was created with your iOS or Android project, but if you create it independently, then you can use the unit test pad in Xamarin Studio to associate another project in the solution with your UI tests. If you expand the tree, you'll find a test apps node. Right-clicking on this node will let you add an application project from your solution. iOS applications will only be selectable if the Xamarin Test Cloud Agent component is included in the application. If not, there won't be a checkbox next to the application. The nice thing about this approach is that you do not need to hard code the path to the application. Instead, it's determined from the project itself. The IDE will build the app, deploy it to the device or simulator, and then run your tests on the app. You can also perform some customizations on the deployment target by expanding the test apps node and right-clicking on the application target. Again, this is in the unit test pad. This will then let you set where the app will be deployed and where the test will be executed. In this case here, you can see we can select the simulator type and size. The last step you'll do in your configuration setup is to tell the UITest to launch the application. This is done through the start app method for both iOS and Android tests. This will cause the application to launch just before every test we run, since it's in the setup method. And it will automatically close any existing instance of the app that's running and then launch a new instance. And this approach ensures that the application won't be in an unusual state and that each test can be coded with the assumption that the app always starts on the initial page. Now, as you've seen, Xamarin UI tests are run as NUnit tests. So if you're already familiar with the NUnit framework, you can create an automated test very easily in order to control the UI of your app. It's important to note, however, that even though we're using NUnit to execute our tests, these are not unit tests. We're going to be creating acceptance tests that drive the UI. NUnit is just the test runner. If you haven't attended the XTC101 class, I highly suggest you do, as we cover a lot of aspects of testing in general and NUnit specifically in that class. Here you can see an example of executing an acceptance test. We'll tap on the Add control, enter some text into the first text field, and then tap on the Save control. With Xamarin.UITest, we can query the interface, touch controls, type into controls, perform gestures, wait for controls to appear and disappear, rotate the device, simulate a change to the GPS, and a whole wide range of other operations as well. Now, as you build out your test methods, you'll likely want to start organizing them into categories. Since we're using NUnit, we'll use the same technique that you would with unit tests. And that's to add the category attribute to each test method. This takes in a string indicating the textual category that the test belongs in. Visual Studio's unit test window can organize by category with the right plugin for NUnit, and Xamarin Studio's unit test pad option dialog lets you filter the test to run based on the category as you can see here on the slide. This allows you to restrict your test runs to new features or maybe to a specific smaller subgroup during the development and early QA phases, and then run the entire suite as you move towards a full release. To actually execute the tests, you just run the test harness. Since we're using NUnit to write the acceptance tests, we can just execute NUnit to run them as well. This can be done through the IDE or from the command line using the NUnit console.exe. One restriction to be aware of, you can only run iOS UI tests from Xamarin Studio on the Mac. It's not supported in Visual Studio yet, although that is on the roadmap for a future release. Android is supported in all environments, Windows or Mac, Visual Studio or Xamarin Studio. When you're first starting with UITest, it can be daunting to identify controls and create the tests that drive the application. A good place to start is the interactive REPL. REPL stands for Read, Eval, Print Loop, and it allows you to try out queries and interact with the user interface in real time. Think of it as a breakpoint in your application, where you can then explore and interact with the UI of the connected application. To launch the REPL, you just use the REPL method on your IApp interface. This will launch a console window where you can type in UITest commands and queries. This feature is only implemented for local UI tests. We'll talk about deploying to Test Cloud in the XTC103 class, but be aware that the REPL is ignored when running in the cloud. One of the first commands you might want to execute in the REPL is the tree command, which will show you the UI of the application that you're testing and give you an idea of what you can interact with. Simply type tree, and the REPL will show a quick hierarchy of the controls on the screen at that moment. Now often, once you have explored the UI with the REPL, you'll want to take some of your queries and then use them in a real acceptance test. You can, of course, copy them right from the terminal or the command window, but the REPL has a great feature to take your entire command history and copy it to the clipboard for you. Just type copy into the window. You can then paste that text into a test and customize it however you like to create the real test. Now, let me demonstrate how we can use the REPL to interact with our application and get some live results. For this demonstration, we're going to explore the Tasky Pro application. This is a sample app that we use in a lot of different classes, and we've included this in your lab materials that you downloaded from Xamarin University. If you come to the lab materials, we have a binaries folder. You can see we have Tasky Pro, and we have an Android and iOS version. For my demo, I'll be focusing on the Android version, but everything we do will be the same for iOS as well. Here in the app initializer of our test demo project, I've specified the APK file to be this Tasky Android.apk in our binaries folder. Now that can come to our actual NUnit test. Here we want to use the REPL, so we'll use the IApp interface, just called app, and we'll choose REPL. And with that, we can then run our test. This will run the test, this will install Tasky Pro, and it automatically launches our command line. On the Mac, this will be the terminal. On Windows, this will be a command prompt. And now we can actually interact with that screen for the Tasky Pro application. Let me make this a little bit bigger. The first thing we can try is Tree. Tree is going to show the hierarchy of the controls on the screen. So you can see here we have an action bar overlay layout, we have a frame layout, we have a linear layout. In that linear layout we have a button. Its ID is button add task and its text is add task. We have a list view with an ID of list tasks. And we have an action bar container, a toolbar, and a text view. This shows us everything that is on the screen. If we want more information about that, we can use our iApp interface that we have here as well in the command prompt. And what's really nice is we get some nice auto completion. I hit the dot and I get all the different methods on the app interface that I can use. And we'll talk about how we can query and interact with the UI in just a little bit, but let me go through and see what's on the screen with a little more information. So I'm just going to run app.query. And this gives us that same hierarchy, but each control has a lot more information displayed. So for example, here we have the Tasky Pro text. This is a Android.widget.text view. Class is enabled. It gives us the dimensions and the location. And we can scroll up and we can see all the different things. So if we wanted to see everything that had Tasky Pro on the screen, we could say app.query and we could pass it a selector. We'll talk about selectors in just a little bit. And there we just have the one. If we wanted to find the button, we could do that as well. And there's our button. Button add task. Well, now let's actually interact with that UI. Let's tap that add button. So we'll do app.tap. And we'll look for that same selector, add task. And then watch the emulator on the right side of the screen. That button got tapped. And now we're at the task detail screen, the enter a task screen. So let's choose tree again. We'll see what's here. Now we have a whole bunch of other different controls. We have txt name, notes label, text notes, and if we do just app.query, we can see a lot more information here as well. And let's look for the edit text. So we have an edit text of txt name. Let's enter some text into that. And we're looking for the txt name, and the text we're going to enter is get milk. And you can see there on the emulator, get milk has been entered. And we also have a txt notes. Let's enter 2% milk. That enters some notes on our screen. And then we have a btn save, a button save right there. So let's tap that. That taps the save button, and now we have a task added to our UI. So we've gone through and we've explored the actual UI running, and we can see the controls that we have. We can see how to interact with them. And now we actually want to make this an automated test instead of having to do all this manually. So let's just type copy. And we've now copied that history to the clipboard. We'll come back to Xamarin Studio or Visual Studio, and we can replace this app.REPL, and we'll paste in our clipboard history. And you can see here, it's everything that we typed into the terminal. Now for our automated test, we don't need to query, so I can get rid of that. The query is just for us. We'll keep the app.tap and the app.enter text, and we now have an automated test. So let's try running that again, and watch the emulator on the right side. And we have a repeatable test. We can then add some assertions. We can verify that get milk shows up in the list, or however else we want to verify that this test actually passed. The REPL is a very powerful tool. You can add that anywhere in the middle of your test, anywhere in your C# and unit tests, and provide a breakpoint to go explore the screen that you're on. It's very useful in determining what your test should look like. In that demonstration, we saw some of the commands that are available on the iApp interface, which enable us to interact with our application. Of course, there are plenty more as well. You can see some of these here on the screen. Query allows you to interrogate visible items on the user interface of the application. Tap will tap on a particular element. Wait for will wait for a specific time. Wait for element allows you to wait for an element to exist. Wait for no element allows you to wait for an element to not exist on the screen. Swipe left will perform a swipe action from the left or from the right to the left of the device. Swipe right performs a swipe action from the left to the right of the device. Scroll up and scroll down. These are swipe actions, but they're renamed because they're more often used for scrolling. And then flash can flash the elements that match your selector. Now, the fundamental feature that allows us to perform queries on the system is the app query system. Many of the operations that you saw in the previous slide work based on the fact that the selector is required in order to define which user interface elements will be performed. You can see the selector here is selecting all the buttons that have been marked with the text Save. The selector has a fluent style interface where you can add additional filters to the user interface elements that you select. In this example, we're selecting all of the controls and then filtering those results to controls that are buttons, and then filtering to the buttons that have the name or ID of Save. Understanding the selector operators is key to selecting the controls that you'll interact with using UITest. Each query that you issue will return an array of 0 or more results which match the given filter. Something to keep in mind is that it's not recommended to cache or save the state of the controls. It's possible that the controls could be removed from the screen, and the app result objects that you're getting back are just a snapshot in time. So let's have a look at how we can identify the correct elements. When we're crafting queries to identify visual things, there are two approaches that we can use. First, we can query for elements by type. We call these class queries. This form of query lets us specify the C# type of control that we're looking for, like a UI button, for example. The second type of query is the marked selector. This allows us to search for a control by its unique identifier or the text that it displays. So here we can see some examples of using class-based queries. We'll pass the lambda expression into the query method, and we'll use the class method to specify the class name that we're looking for. Keep in mind that these are case sensitive. And then since we might want to use similar testing code between iOS and Android, or just because you want strongly typed code checked at compile time, we also provide some abstractions for common elements. Here we see an example of using the button and the text field methods, which would translate to the UI button, or the UI text field, or the edit text on iOS and Android respectively. In addition to selecting elements by their type, we can also query for elements with some text. The marked method will look for any elements with the specified text in its ID, accessibility ID, or its text property. Notice again that we can chain these selectors together and only look for buttons that have the specified text. Now in UITest 0.8.0, a shorthand syntax was added to all the query operators to make common queries easier to build and read. You can now pass a string into the query operator, and it will use a mark selector to find the given control based on that text. Either syntax is fine, they'll end up doing the exact same thing. The second one's just a little shortcut. Here we can see some of the fairly common queries that you'll use to interact with the app. When we want to see a list of all the visible elements on the screen, we can use the app.query with no selector. We saw this in the REPL demonstration. If we want to select elements specifically by their unique ID, we could use the ID selector. If we want to select elements with the ID or accessibility ID or text, we can use the marked selector, including the shorthand version where we just pass in the string that we're looking for. We've already seen that we can use the abstracted methods such as button to select all the elements of that type, regardless of platform. We also talked about the class selector, which allows us to search for any control of a certain type or derived from that type. And when we use the app.query with no selector, again, we get all the visible elements on the screen. On the other hand, if we want to select both visible and invisible elements, we can use the all selector. And then lastly, if we're interacting with a web view or a web view-based application like a Cordova or PhoneGap application, we can use the CSS selector to run CSS queries on the HTML in the web view. This is also useful for native apps that might be using OAuth, which generally launches a web view in order to log into the authenticating site. When you use the CSS selector though, you're returned an array of a class called app_web_query. So at that point, you can't use the fluent selector syntax like you would for other queries. Now in the XTC101 class, we discussed the format, syntax, and flow that we want to use when we're writing unit tests. Well, creating an acceptance test with Xamarin.UITest still fits in with that same process of writing regular unit tests. So we use the same basic flow for the test: arrange, act, and assert. Where this will differ in comparison to unit tests is in the arrange section. We won't be creating real and mock objects or setting up our data. Instead, our arrange section will simply install and connect to the application. We'll use the Xamarin.UITest.configureApp class and choose either iOS or Android as appropriate. Either way, we'll then pass in the path to our IPA or APK file. Our act section of our test will be similar to a unit test, in that this is where we will actually interact with the elements that we want to execute and test. In this case, it will be user interface elements. Then finally, in the assert section of the test, we can use NUnit's regular assert class methods to validate our expectations. Now we're going to take a flash quiz. The flash quiz is meant to reinforce the material that we've covered so far. I'll read the questions on the screen, and you should answer to yourself as we go through them. Question 1. The REPL tool can perform what operations? Choose all that apply. This could be more than one answer. Is it A, query the user interface? B, list the contents of the view hierarchy? C, copy previous operations to the clipboard? Or D, add new controls to the user interface? The REPL tool is a read-only tool, except for entering text into fields. We can't just add random controls to the user interface. Question 2. The command to type in a control is A, type text, B, enter text, C, use keyboard. We'll use the enter text method, which hangs off the IApp interface, in order to enter text in the control on the screen. Question 3. The query operation by itself will show all controls, both visible and invisible, on the device. Is that true or false? That's false. By itself, the query operation will only show the visible controls. If you want to see the invisible and visible controls, you'll use the query operation and pass in the all selector. Now we're going to work on an individual exercise. And this exercise will give you a chance to get some hands-on experience with writing acceptance tests with Xamarin.UITest. Please open the Start Here.html from your downloaded materials. Scroll down and click on Exercise 2. We'll be testing a pre-built application, Tasky Pro again. We'll configure the UI test, connect to the app, and then get it to add a task. If you're using Xamarin Studio on the Mac, you'll be able to test either iOS or Android. If you're on Visual Studio, you'll be testing Android only. Please read through the instructions carefully. This exercise is meant to take about 20 minutes, but you can take as long as you need during the video. Now, please pause this video, work on exercise 2, and continue the video when you are done. Now, let's take a moment and review that exercise. Here I have loaded the completed solution from the Part 2 exercise, and you can see that we've written 2 tests. We have Tasky Pro creating a task should be successful, and Tasky Pro deleting a task should be successful. Let's go ahead and run those against Android. And there in the test results pad, you can see that both tests passed. You should have that same result. If you had any issues with that exercise, please try loading the completed solution and running that. At this point, we've covered the introduction to UITest, looked at quickly querying a running app with the REPL tool, explored the query syntax, and we were introduced to some common queries. And at the end, we built some actual acceptance tests. In our last objective, we went through the basic details of creating a Xamarin UI test. Now, let's dive a bit deeper and discuss some real-world problems and good practices you should be using in your tests. In the next few minutes, we'll look at some of the strategies that we can use when developing cross-platform tests, where we have similar tests running on both iOS and Android. And we'll talk about the platform differences that we'll come across. Now, there are many times where you'll want to develop acceptance tests for the same application that's running on different platforms. In these situations, you may have 2 similar interfaces that you're working with, but if you look at the user interface of the Android application and the user interface of the iOS application, they're running 2 completely different interface styles. For example, maybe the Android application is using fixed controls, while the iOS application is using controls that are embedded in a UI table view controller. Well, one solution is to create a different test suite for each platform and then try to keep them synchronized as your app evolves. And that's not an ideal solution, but you could take that approach. What we'd ideally like to do, however, is to write the tests once and have them be shared on both platforms. To take this approach, we'll need to provide a level of abstraction so that we can isolate differences in the UI which affect the tests. And we'll typically do this by providing an interface to interact with each screen that you want to test. Let's take a look at an example. Here you can see we've defined an interface for our Enter Tasks screen. This exposes a Fluent API where each method returns the interface back so it's easier to work with. The interface API provides access to the specific UI things that we want to test, setting the task name, notes, and pressing buttons in the UI. Now, once you have your interface for the test defined, you would then write a concrete implementation of this class for both iOS and Android, using the proper queries for each platform to identify the things that you're working with. You can then begin to write your actual acceptance tests using the abstracted screens, as you can see here. Notice how the Fluent API allows us to write tests in a more functional fashion. The process of creating cross-platform tests uses the same techniques that you would for a cross-platform application, which we cover in the XAM.110 Introduction to Cross-Platform Applications and the XAM.300 Advanced Cross-Platform Applications class. As we've seen, the platforms are different, and as a result, you'll need to identify and interact with different controls in order to make sure that the tests work properly on each platform. Recall that we have 2 types of queries we use to identify visual things: class queries, which work with types, and mark selectors, which work with the identifiers or the text of the control. And these queries will often be different on each platform. So let's look at what we will need to change. Class queries are obviously different between platforms because we have different controls. But interestingly enough, they actually work differently as well. The iOS query that you see on the slide will look for a control of type UI label, or any subclass of UI label. On Android, if we specify the class name only, such as TextView, as you can see here, without the namespace, we'll get all the classes that end with that class name, but not the subclasses. So for example, it would return Android.widget.textView or mynamespace.textView. On the other hand, if we use the full namespace of the class, like Android.widget.textView, then we'll find all instances of that control and also subclasses of that control as well. This is an important distinction that you need to make when working between the platforms. The mark selector works differently as well, in that it searches different properties on each platform. On iOS, the selector will search through the accessibility identifier and the accessibility label of the views looking for the specified value. Most of the time we don't set those fields, however. They're really intended for screen readers and other assistive accessibility features. In fact, we didn't set these properties on the tests we've run so far, but we were still able to identify controls using the text value. Well, it turns out that iOS automatically copies the text property on labels, buttons, and other views that have a text property into the accessibility label property. So if you don't deliberately set the property, it will ultimately match the text associated with the view. However, if you do set the accessibility label, then the text property won't be matched against it, so be aware of that restriction. For controls that don't have text, you should prefer the accessibility identifier property. And this is quite different on Android, where the mark selector checks several fields on each control looking for a textual match. Typically, you will match against either the Android ID field or the text property. If you're using Xamarin.Forms, then testing your app in some ways is not much different than a native UI app. First, remember that in Forms, you work with a logical tree of elements created in code or in XAML. A platform renderer then takes that logical tree and turns it into a platform-specific visual tree. So for example, if you define a button in Xamarin.Forms, then this will become an Android.widget.button on Android, a UI button on iOS, and a System.Windows.Controls.button on Windows. You can use the class and the mark selectors just as you would with a native UI application. Marked will see the text set on the elements, and class will pick up the native generated visual tree just fine. The problem comes in when you want to use a control that doesn't have text. Since you can't set real properties in the visual tree beyond what Forms provides, queries on those types of elements can be difficult. So how can we pick these types of elements up? Well, the key is to set the style ID property on your testable elements. This property is not used in Xamarin.Forms directly, so it won't impact your application behavior at all. But once we've set this property, we can then map it to native properties which will be picked up by the mark selector. Now keep in mind that even though Xamarin.Forms supports Windows, UITest does not. So you'll be limited to just the iOS and Android apps at this time. The team is looking into Windows Phone. It's on the roadmap, but we don't have support for it today. So let's look at how we map this logic property onto something that marked method will look at. This will be a platform-specific bit of code, and we'll need to add this into each one of our platform-specific projects. Now, on both platforms, we can hook into the static Forms.ViewInitialized event, which is raised each time a visual element is created. On iOS, we'll want to do this as part of the app initialization, so we'll put this in the finished launching. In this event handler, we can copy the style ID from the passed in view over to the passed native view's accessibility identifier. Remember that the marked method searches this property. This will make our views findable through the style ID value in our tests. Also, as you can see here in the slide, make sure to start the automation server in your iOS application. And then similar code is added into the Android project. Here we want to map the style ID to the content description property, which is also searched by the marked method on the Android platform. With these bits in place, we can then create queries which will locate non-textual elements very easily through a unique ID controlled by the developer. In fact, you can use this approach for every control if you like. It can provide a level of consistency to your code which can help keep things ordered as you build out your UI tests. Let's talk about some of the other things you might want to do in a test. First, there may be some features that you activate which must be manually verified by looking at the screen. Well, you can get the test to take a picture through the screenshot method. The resulting picture is placed into the bin debug folder where the UITest binary is running from and given a name like screenshot-1.png. When you're doing local testing, like we are today, you have to deliberately enable this feature in your configuration chain by calling the enable local screenshots method. This isn't necessary when you run on Test Cloud. Screenshots are always supported there and they're captured as part of the test run. The advantage to this is that you can turn off all local screenshots by commenting out the single call in the configuration chain. You can also optionally name the screenshot by supplying some text. This is only used in the Test Cloud version, but it provides a title to more easily identify the scenario. You'll only see this name in the local versions in the test results, which will identify the file name and the title given. Now, occasionally, your test will try to execute faster than the application or the device responds. For example, you might need to wait for an animation to finish, or a file to download, or an element on the screen to appear or disappear. Using thread.sleep in those scenarios isn't recommended, and it's not really responsive to how the application behaves. You'll find that waiting tends to produce slow and flaky tests because the devices and the backend services will respond with different latency when performing operations. Instead, it's best just to wait for the elements on the screen to either exist or not exist as part of the test. When navigating to a screen, if you're relying on a storyboard to present your UI with no custom animations, then you don't need to explicitly wait for things. If you dynamically add and remove content in the code, then you might need to wait for an item to appear before you can interact with it. And of course, if actions you perform cause things to change in the UI, you'll need to add in waits for things to appear and disappear before testing. So instead of sleeping, you should use the wait for element and the wait for no element methods. These work properly with the UI thread to continue to perform UI operations, but they pause the test until the proper element either shows up or disappears. You would typically wait for an element when you're presenting a new screen, or you expect an item to be on the screen. You would use the wait for no element when a screen is disappearing or an item should eventually be removed from the screen. When using these APIs, you pass in a time limit to wait and a timeout message if the element doesn't appear or disappear in the expected time frame. Now, we've already seen how to tap and activate items, but what about other gestures that you use in an application? Well, UITest supports some basic limited gestures that you can use on your UI elements. These include swiping, scrolling, zooming, and the long press gesture where we touch and hold. Most of these gestures are passed a query to identify the control or the element to perform the gesture on. But there are some that take an X and Y coordinate. So you see two here, drag coordinates, which lets you do dragging operations, and flick coordinates, which performs a flick gesture from a starting point to an ending point. In addition, there are several others not shown here that deal with specific coordinates. For example, there's a double tap coordinates that takes an X and Y position to double tap on instead of a specific element. The basic gestures are easy to use. You just pass in a query selector into each one and it taps, double taps, swipes, pinches, or scrolls. But these gestures can only be applied to a single visual element, and that element must be visually present. If you need to perform more complex gestures, such as dragging between areas, or gestures that overlap different UI containers, then you have to rely on the coordinate versions of the gestures. So here's an example. We want to swipe left in a given container, but start the swipe in the center and end on the left side. In this case, the built-in swipe gesture won't work because we need it to start in a different spot and we might be crossing multiple children, so we can't position the swipe properly by element. So we create a new method to do the swipe for us. We pass in the ID of the container into our method. It calls a static method to get the height and the width on the running device, and then it uses the drag coordinates method to perform the swipe. You can use this same technique to create all sorts of complex gestures to drive the app if necessary. And there are numerous apps out in the marketplace where they are really just a wrapper of HTML5 based functionality embedded in a native app. And these applications don't have the native app elements included in them. However, they do have web views that we can analyze and process with Xamarin.UITest. Making use of this allows us to test these applications regardless of what tool we use. We can use the CSS selector in our queries to determine which element we want to look at. And then finally, there may be some tests you want to perform which require a lot of setup or navigation through a bunch of screens. Or maybe you want to clear out your local database between tests. Rather than writing long, complex navigation steps, you can take a more direct, some might say dirty, approach to invoking the methods directly in your app. You can place public methods into the app delegate for an iOS application or the global application class for an Android application, and then call them from a UI test. This allows you to shortcut into the app, executing some internal testing-only logic. It's good practice to make sure that these methods are only exposed in your testing builds. Let's continue with another flash quiz. Again, I'll read the questions on the screen, and you can answer to yourself. Question 1. Changing platforms or idioms do not require you to alter tests. Is that true or false? That's false. Of course, having different platforms will require some changes to your tests. Question 2. What is the purpose of the class full selector? A. It looks for exactly the same class, including the namespace. B. It looks for full implementations of the class's interface. Or C. It looks for implementations of the class fully visible on the screen. The class full selector is going to look for exactly that same class, including the namespace. Let's take a moment now and work on another individual exercise. Open your Start Here.html worksheet and click on Exercise 3. For this exercise, you will be writing your acceptance tests in a more cross-platform, reusable way. Again, please read through the instructions carefully. This exercise is meant to take about 20 minutes, but again, you can take as long as you need during this video. Now, please pause this video, work on Exercise 3, and continue the video when you are done. Let's quickly review the completed solution for Exercise 3. Now here in our test file, we can see how we've refactored our code to make it accessible for both Android and iOS. We've extracted out an interface that will describe our user interface regardless of platform, and then we'll provide a concrete implementation for iOS that knows how to talk to the iOS screen, and Android that knows how to talk to the Android screen. Now let's go ahead and run those tests. And now you can see those tests passed for both iOS and Android. We've now taken a look at some real-world problems and solutions associated with writing our tests. We've been doing local UI testing with our simulated devices today. However, to really try out the app, we eventually need to test it on a real device. You can deploy these exact UI tests to real devices, and we'll cover that exact topic in the next class in this series, XTC102. In addition to local devices, we'll also look at pushing those same tests up to a cloud testing environment because, as you know, there are far too many devices on the market and no way to adequately test that your application will work on the huge range of devices. While exceptionally powerful in a local environment, the true power of Xamarin.UITest lies in the fact that you can take a working local test case and push it to Xamarin Test Cloud with no modifications, scaling out your testing efforts across a pool of more than 1,000 real, non-jailbroken Android and iOS devices in a cloud environment built for performance and stability. So we'll look at how to take our tests, and then we'll do the same UI testing on a variety of devices, operating systems, and form factors using Test Cloud. Thank you for watching XTC102, working with Xamarin.UITest with Xamarin University. If you have any questions, please post a question in the Xamarin University forums or schedule some office hours with a Xamarin University instructor. Thank you, and happy coding!